All right, guys, this is your next lesson in Chapter 5. Hopefully, you didn't have any trouble with Section 5.1. Nobody emailed me to ask me anything about that, so I'm assuming it went okay. I don't think this red's going to show up very nicely on this, so let me just change it to this blue. Let's see what that looks like. Yeah, that'll work. Um, so you've been doing linear functions for a long time if you've made your way to grade 12 math. So this is no different. In fact, maybe this is even more basic than what you're used to. Just the y and the x represent your points on like a coordinate system where you got your y there and your x is there. The m is your slope. Remember, rise over run, y2 minus y1 over x2 minus x1, delta y over delta x, that sort of thing. And the b is the y-intercept. Let me just erase this. The y-intercept is where your line hits the y-axis. It looks like I'm spelling the word they. The y-axis. And the slope, it's the rate of change. Why don't we say it's the steepness? We can also say that it's y2 minus y1 over x2 minus x1. That would be if you have 2 points on your line, and we'll probably be using that today. Some people just say rise over run. All things that can be attributed to that m value. Maybe I should know the answer to this. I don't know why they call it m, but I always call it m. So let's get into some linear models here. A linear model represents quantities that either increase or decrease by a constant amount over equal intervals. I'm just going to switch back to red. I don't know, just because I want to. For a linear model, that when you graph it, it makes a straight line. It follows an equation of the form y equals mx plus b, and the first differences are equal. Those are the properties. And at this point, I'd ask you if there are any questions, but I don't think I'll be able to hear you. Shout them out if you want. Maybe I'll hear them, maybe I won't. But the rest of this first lesson here is just a few examples, all right? So here's some data. Calculate the first distance to determine if the relationship is linear. Hopefully it is. So you can see the x just goes up by 1 each time. Up by 1, up by 1, up by 1, up by 1. -2, -1, 0, 1, 2. The next number would be 3, right? So if it's going up by that constant, just up by 1, the y has to be changing by a constant rate. So what's the difference between 4 and -1, -1 and 2, 2 and 5, 5 and 8? Now, for some people, the negative numbers will throw you off. So why don't we even start at the bottom? What's the difference between 5 and 8? That's 3. 5 plus 3 is 8. What's the difference between 2 and 5? It's 3. And then we kind of see our pattern. Then we look up, all right, well, -1 to 2. If I'm counting up from -1, go -1, 0, 1, 2. Difference of 3. Now, and if you don't believe me, if you want to check it, go go to subtract 3, and it should give you your -1 back. Same if you go from -1, if you subtract 3, you'll get back to -4. So it works both ways. So since your first differences are all equal, that tells us that it is indeed linear. That's pretty much illegible, but it is a linear function. Let's graph the data and let's find the equation of the line. All right. So this could be a little bit challenging for me here on this touch screen, but I'm going to do the best I can. So let's go -2 and 4, -4 first of all. So here's my -2, there's my -4. So there's a point right there. Let's see how it goes. -1, -1, all right. 0 and 2. 0 and 2 is right here. 1 and 5 and 2 and 8. Right there. I'm not going to be able to put a ruler on this, and you should never ever do this if you're handing something in. But there is a freehand line that looks like kind of a line. Sort of a line. Let's try it again, though. That one is marginally better. Graph the data. I'm saying that that's done. Graph the data. Determine the equation of the line. All right. So here's what we can do. Write y equals mx plus b, because we need the equation to be in that form. Y equals mx plus b. So there's actually a few ways that we could do this. We just need to insert the slope in the y-intercept in this case, and we know, well, let's start by putting in the y-intercept. Y-intercept, remember, is where it crosses the y-axis, so that's right here. It's at the 2, so why don't we put 2? All right, now we're getting somewhere. Now the other thing we have to input is the slope, the rise over the run of this particular line. So there's a couple of ways we could get that. One of the ways that we can get it would be to put in a point and then just solve for m, but that's going to require some algebra. So I think we can just get the slope the old-fashioned way by just going like this. Go to wherever you want. I'm going to choose to go to there. 2 up to 8 is a rise of 6, and it is a run of 2, because it's going to there. Started at 2, ended up at 8, and it was so a run of 2, a rise of 6. So that means my slope, which I'm just going to write m here, is 6 over 2, which is 3. All right, so my equation of the line is 3x plus 2, and done. And it's going to be about that easy. This is the last example. It says a landscape company pays its workers an hourly wage. Every year, the employee's hourly wage increases by the same amount. Well, right there, that tells you that it's going to be linear. A worker with no experience, so let's say that x equals 0. Yeah. Earns $9.50 an hour, and a worker with 5 years experience, so x equals 5, gets $13.50 an hour. Now our graph here does not go that high. So I'm going to modify this graph. We're going to say that the y is our hourly wage, but we're going to go 10 and 20. Actually, maybe I'll delete that whole graph and just, no, I'll just run with it. We'll run with it. We'll make this, I'm just going to change some of these numbers here on the y-axis. We're going to count by 2s instead. So forget these ones. We're going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, and that should be plenty. Now, the reason I changed those, in case you're thinking I'm just gone insane, is that I got to get up to $13.50 per hour. And the y-axis only went up to 9, or I guess at most 10 if I use that top spot. Anyways, so 0 experience, so that puts me right here. That's not the point, but I'm just trying to point out where I'm starting at. Gets you 950. So where would 950 be on my graph here? Again, I want to make sure we're not using these numbers. We're looking at my red numbers there on the left. So 950 would be right about there. And I'm going to circle that point to make sure we see where it is. And for 5 years experience, so now I'm looking over here at my 5, I'm getting 13 and a half, 1350. So I go up here, up, there's 12. 13's right in between the 12 and the 14. 1350 would be right about there. I circle that, and then I'm going to join those 2 points with as straight a line as I can freehand. Hopefully that's going to be good enough. So draw a sketch of the graph experience versus hourly wage. Good enough. Determine the slope of the line and explain its meaning. All right, so the slope of the line is going to be the rise over the run. So the run's easy. It's 5 because we went from 0 to 5. No experience to 5 years experience. The run's a little trickier. It's going from 950 up to 1350. So how much is that? It's a rise of 4. Let me just write those numbers there. 1350 from 950. And basically the rise is just, well, how far did you go from there to there? And if you do the math, it's going to end up being a $4 increase. So I'm just going to write 4. Another way to do that mathematically would be to go 1350 minus 950. That would give you your y2 minus y1, like I wrote on one of your slides there. And that should give you $4. So let's go, let's write that in here. So we go determine the slope. So m equals rise of 4 over run of 5, which is equal to, I believe, 0.80. So that's the slope. But in order to explain its meaning, it's dollars per year's experience. So I'm just going to put years EXP. And that helps us express, like, what does that mean? It means you get 80 cents more per hour per year experience. After 1 year, you'd get 80 more cents per hour, then 80 more cents per hour, then 80 more cents per hour to get your way up to that 1350. It doesn't tell us what happens after the 5 years. It just tells us that it goes up by the same amount each year. To write an equation for the line, I'll start with the generic form y equals mx plus b. And that's going to be y equals. Now I know that it's 0.80. You could put the dollar sign in there, but I don't think it's necessary. Plus, what's the y-intercept? Well, it crosses at 950. 9.50. And it would not be incorrect to put the dollar signs on each of those values. Remember, it crosses right here at 950. What if you had 12 years experience? Calculate the hourly wage of an employee with 12 years experience. All right. So that's why we have equations like this, to predict what would happen later on. So I go y equals 0.80, and we want to go with 12 years experience plus 950. You can punch all that into your calculator in one step. Go 0.8 times 12 plus 950, and it gives me $19.10. Now, I highly doubt a real employer would increase your wage indefinitely. What happens when you're at 30 years experience? Just for fun, if I put in 0.8 times 30 plus 950, then you're at, a really, really high amount. Because just the 0.8 times 30 is $24. So it's like $33 an hour or something crazy like that. Anyway, so that's about as crazy as this y equals mx plus b stuff is going to get for you this year. So on page 293 in your textbook, I just want you to submit for me numbers 1 to 7 and 10 to 12. That should be good enough for linear systems. On Wednesday, we'll be going over the same sort of depth, but for quadratic systems. Won't be nearly as crazy as grade 11 or grade 10 math. Submit pictures of your work as usual. What else was I going to say there? Oh yeah, I'm going to take, I know there's at least 1 or 2 of you that didn't bring your textbooks home. So I'll, if I forget for some reason, just go ahead and send me an email and remind me that I have to post pictures of the work. Okay. And I'll only be posting pictures of the pages with the questions you have to do on it. So if you want the section to read over yourself, you can also email me that, and I'll fire up those pictures as well. It's just on my rural internet. The more pages I got to upload, the longer it takes. Quite a bit longer. Anyway, that's all for now. You guys just keep on rolling through this stuff. Let me know if you've got busy work schedules and stuff like that. I can give you extensions, whatever you guys need, just as long as we keep moving forward and getting through this stuff. All right. Good luck.